Hi, Josh Snyderman with Learning Blade here, and I am excited to talk about our lightweight aircraft mission challenge called the Aluminum Boat Experiment. In this experiment, students are going to use simple materials, tinfoil, pennies, and a ruler, and a bucket full of water, and they're going to construct tinfoil boats that will then be used to measure how much mass can it carry. This is showing students how density and buoyancy work and really giving them opportunities to explore volume and mass as well. So let's get started with this, one of my favorite classroom experiments to show your students how to begin experimenting with buoyancy. So this mission challenge, the aluminum foil boat, comes with a worksheet where students are going to measure the volume of their boat using length, width, and height. Now as a teacher, I tried to create identical sheets of tinfoil. So this is in a way a competition because everyone has the same size tinfoil, but the volume of their boat will be different. Quite honestly, some students will make boats and they'll try to make a canoe. And so they'll make a canoe shape because they're familiar with canoes. And that is, in the end, not going to be the most effective shape for their boat. So many students will come to this design making a canoe shape. And I let them do that. It's a very hard shape to get the volume of, but they might come out and build a canoe. Okay? But this is not the most maximum volume that a student could have. If you wanted, you could have the students use the size of the paper to think about the maximum volume in advance. Because obviously, the larger the volume, the more water it will displace, therefore the more buoyant the boat. We also have used pennies to determine how much mass the boat will carry in the water. You can have your students mass pennies in advance of the lesson, maybe put 20 pennies on a scale and divide by 20 to get the average mass of 1 penny. And then when their boat carries 35 or 40 or 50 pennies, they can just use their mass of an average mass of 1 penny to determine the mass of their boat was able to carry. Interesting note on pennies, in 1983, they changed the amount of copper in pennies. So pre-1983 are more dense than post-1983, which is a good reason to get an average. Okay, I'm going to go ahead and build my boat, trying to maximize for volume. There's lots of things that will affect the amount of pennies your boat will place. Number one, some students will drop a penny from too high and it causes the boat to sink. Another thing you might want to do is move the pennies around so they're evenly displaced. And this is what I think is, personally as a science teacher, one of the things that's most interesting. The mass of the tinfoil is maybe a gram or 2. How is it possible that 1 gram of metal can carry hundreds, if not thousands of grams of mass? And this is why an aircraft carrier can be made of steel and float on water. Obviously, the design of the boat will change many elements of how many pennies your boat can hold. As the boat adds mass, the boat sinks in the water. The amount of volume being displaced is equal to the mass of pennies being added to the boat. It's really a beautiful principle. And then when students are done and the boat sinks, they would count the number of pennies and finish their worksheet. I could probably keep adding pennies, but I will just show you what happens when that last penny is added and water gets in. The boat will start to sink. So that is the tinfoil boat experiment. And I can use my worksheet to gather and collect my data and then interpret my results. And that's how this experiment works. Make sure to check the resources section of your teacher account under the mission challenges to find all of our mission challenges. Come back and watch some more of our videos.